in that bucket, we have the OpenAI services, the Cohere, Anthropic, and also the Amazon Bedrock. So probably this option, the fully managed service, is the easiest way for customers to build LLM application, because essentially customers just have to call the single API to build their LLM application. However, there are some challenges for customers who are using this solution. For example, the first challenge is some customers complain about this is a black box API experience, which means lack of data security. So what if customers don't want to send their sensitive data to the cloud through API? And also the second challenge for them is the lack of customization. So what if customers want to use their on-prem hardware for prompt engineering and fine-tuning? Or what if customers want to import any of the custom model into their platform? And then the third challenge is also important, because customers might want to lower the cost, especially the CapEx, due to the pay per token. So what if customers, they want to run their LLM application 24/7? Then the cost probably will be very high for this option. And then the second option in front of a customer is to build their tools by using the open source tools. So here, this is probably the most flexible and customizable way for customers to build their application from ground zero. But however, there are also some challenges. The number one challenge is for customers to pursue this route, they probably need both in-house AI experts and also the in-house infra experts for them to get started. And also that means they need to spend time to build down the homegrown solution and also to maintain that homegrown solution. So that means cost and time. And then lastly, it's very important for customer to scale beyond the prototyping. But however, some of the homegrown solutions, they really focus on the prototyping and they never get a chance to go to the production environment. So that's why essentially the questions for enterprise is if there's any middle ground between fully managed service and also the open source tools. Or in other way, the questions for the enterprise customers is should I buy versus build? If there's any option between build and buy. So that's why we are. So that's why we find our solution, GenAI Studio, is very helpful for those customers who want to find the middle ground between buy and the build. And introducing GenAI Studio, which is a feature of MLDE. And in one sentence, GenAI Studio allows customers to quickly prototype and validate ideas on day one, and then ramp up for their production needs on day two. So what does that mean for day one? So on day one, we provide a very easy interface, the UI-driven experience for customers to use the off-the-shelf curated foundational models, such as Llama 2, Falcon, and MBT, so that they can start the guided and the reproducible prompt engineering on day one, and also use the one-button fine-tuning to customize their models. So everything should be done within 1 day and very quickly to help them to identify and validate their ideas. And then for day two, after the ideas get validated, they can decide to productionize the prototype by using a lot of capabilities that we offer to the customer, including monitor and manage the resources, the GPU, to make sure GPU are fully utilized for prompt engineering and fine-tuning. And also customers can track experiments to have a deeper understanding of the data pipeline and also have a better control of the model, so that they can feel comfortable to productionize the model. And also we support the Jupyter Notebook experience where customers can import their custom model and also build more pipeline. So that's the parts that Simon will have the deep dive for today's session. And lastly, but not least, the security first. So based on the conversations that we have customer, quote unquote, security, the data security and the privacy cannot be an afterthought or bolt on later. This because security must be guaranteed in order for them to consider operationalize LLMs. So that's why we take security very seriously, and that's why we enable customers to self-host their models, whether on-prem or using their own cloud environments. So that's why customers can have the full control of their entire pipeline. So with that being said, I'll just showcase a very quick demo of our environments, and then so this is a day one experience that I'm gonna work through very quickly, and then after that so we'll move to the day two experience, the notebook experience from Simon. Okay, so this is the interface that we're looking at. So on day one, so if I just want to quickly kick the tire, then I can go to the playground. So I can select different models. So here I use the Llama 2 7B chat. Also, there are some other already curated model for me to select it. And I can also select the resource pools. So here, I can choose between A100 or V100. So if I use V100, and then I can change different temperatures, the maximum token. So everything just out of the box. So very easy for me to just try this out. And then for this very simple use case, so imagine I'm a data scientist. I want to help my contact center customer support representatives to summarize a very long ticket. So this is one ticket from the contact center. So I can just generate. I can see my instruction is to summarize the inputs within 20 words, and then the summarization is pretty short and concise. And then after that, I also want to try a more complex use case, which is a data set. So essentially, I have a data set that has more than 30,000 rows. So one column is the raw information that has all the customer complaint narratives, and then the second column has the category in terms of which classification that tickets will fall into. So basically, I want to use these data sets to evaluate Llama 2 7B to make sure the Llama 2 7B is good enough for me to build my application for the representatives. So here, after loading these data sets, and also I can write a very specific prompt in terms of the instruction. So here is, you are a customer support expert in financial industry. So your job is to help me classify the customer complaints into 10 different buckets, so that the right tickets will be moved into the right buckets. So here I can click just one button, generate, and then I can generate all the results based on those more than 30,000 rows. So very easy for me to generate the results, so that I don't have to categorize the tickets one by one. So here, so for example, there are two rows, two columns. The first column is the generated outputs. The second one is the expected outputs. Essentially, I'm getting the prediction versus the ground truth. So that's why it's very easy for me to compare the prediction versus ground truth. So I can see whether Llama 2 7B chats is good enough for this more complex use case. And because I can see there's a lot of mismatch, so maybe the insights I take from this prompt engineering work is probably this Llama 2 7B is not good enough just for this complex use case. So probably that's the moment for me to decide that, hey, maybe I should invest my hardware in order to do the fine tuning. So that's the moment I can just do the fine tuning using the click-through experience. So very easy to do the fine tuning. Just selects all the information available and selects the hardware that you want to use for the fine tuning. Everything is just a click through, very easy to follow. So you don't have to write any single line of code to do the fine tuning on day one. So because fine tuning will take some time, so I'll just go to one of the fine tuning job that I have done. So for example, one fine tuning I done yesterday is this one, 1833. So if I open this one, so I can see this learning curve, a very nice learning curve in terms of the evaluation loss. And if I want to dive deeper, I can go to the code to see all the parameters, all the codes behind this fine tuning. So that's the moments that I'll be transferred to the day two experience, because that's the moments I realized that maybe I need to do more customization to understand better about my pipeline, and maybe I can do more stuff within the notebook. So with that being said, I'll pass this to Simon.
Thanks a lot, Ron. And yeah, thanks also for showing us through the notebook experience and walking us a bit over day one. So my part of this webinar is now really basically focusing on day two. So the point where you say, all right, this is the graphical user interface, and that works well, that really speeds up that really helps me speed up building my large language models, fine-tuning them, evaluating them. But of course, a graphical user interface isn't everything, right? There are cases where you really want to dive into the code side of things, and there can be multiple reasons. A typical reason is, for instance, you want to use GenAI Studio or its capabilities from inside an automated workflow. Think about that, right? You have some data processing going on, then you want to kick off a fine-tuning of a model, for instance. And also that is something that typically you don't want to do via the graphical user interface, but you want to do via one step in your automated workflow. And that's really where the code part, the code interface to GenAI Studio comes in, the lore SDK. And that's what I'm going to be focusing on. And that's also the point where I'm starting to share my screen. And I do hope you can see that screen now. Sorry to interrupt.
We're just going to finish up this poll, but then after that, feel free to dive in.
Perfect.
Yes. And I can see your screen.
Okay, that's great news. Okay, so I see the poll. That's actually quite good because one of the top voted options is summarization. That's actually a perfect segue also to my part. Well, what we're going to do over the next probably 30 minutes roughly, we are going to understand how we can use the lore SDK, so the Python SDK that comes with GenAI Studio, to walk through our classic process that we want to typically employ when we talk about handling large language models. So we are basically going to understand how can we load a model with the lore SDK, and we're gonna see different ways how we can load models from an arbitrary model from Hugging Face, a model from GenAI Studio directly that ships with GenAI Studio, one of these base models, Llama or Falcon or MPT models, for instance. We are then also going to go into loading a data set. Also there we have different options using the Python SDK. We can plug into a Hugging Face data set. We can create a local data set and push that to GenAI Studio. But we can also just use a dataset that's already in our GenAI Studio dataset pool. We're then once we have a model in the dataset, we're gonna define a prompt, push that into a prompt template, and then actually apply our model on our dataset using our prompt. And that's also why I said the poll is a good segue, because we are gonna do this in the context of a summarization task. We are going to be summarizing archive abstracts of scientific articles from archive, and we're going to see how our model performs on that, and then move on to fine-tuning that model. On step number 5, we're going to see how we can fine-tune our model using the lore SDK, but not only that, also how we can evaluate our model using GenAI Studio and the lore SDK. And I think that's also a good point to make. The lore SDK operates at a lower level than the graphical user interface. So that means, well, on the one hand, yeah, you can just use Python and wire it into your automated workflows, but not only that, it also has additional functionalities compared to the graphical user interface. So it's really a superset of things you can do on the graphical user interface. The superset of it you can do using the lore SDK. Once we've then fine-tuned our model, we're going to move on to, well, again, evaluating it. Of course, you want to understand, does it now work actually better on our summarization task than the generic model did? And we then want to push that model, want to use it somewhere. So we're going to see how we can register our model back to GenAI Studio to also make it available from the graphical user interface for myself, but also for other users to use potentially. And we're also going to, in our last step, understand, well, what now? Now we have a model fine-tuned and, well, it hopefully works better, but what now? And we're going to see that, well, we can very easily in one line of code push it to Hugging Face again for usage from there, or we can download it and use it, well, anywhere where you basically want, right? Use it in your deployment pipeline, deploy it into your application, whatever you really want. So that's kind of the high-level outline that we're going to go through in the next 30 minutes. Yeah. So the lore SDK is something that is being developed by us at HP within Determined AI, and it's basically really a collection of Python logic or Python package, you could say. And the first thing that we do when we use lore is, well, we got to import the client. That client is really going to be our entry point to GenAI Studio. And for hooking up that entry point to our GenAI Studio instance, well, we first need to set up that client. That's fairly easy to do. We're just going to point it to our host where GenAI Studio is actually running. And we want to log in, we want to authenticate. So we pass some credentials as well as set a workspace. So similar to MLD, machine learning development environment, which GenAI Studio is part of, also GenAI Studio operates with workspaces. So whatever I'm going to do here, that happens within my personal workspace, also to provide a level of isolation between users and teams. So let's move a bit further down. At this point, well, our client is hooked up to our GenAI Studio instance. So everything we are going to do, we are now going to do in the context of our GenAI Studio instance. And when I say GenAI Studio instance, this is really, well, the web interface where things that we are going to do is going to pop up is really what Ran showed you. And I'm also going to be switching a bit back and forth between the web interface of GenAI Studio as well as our notebook, because it's important to understand it's just two different entry points, right, to what's happening under the hood. So if we fine-tune a model here, that means we're going to see the fine-tuning run also in our web interface. When we push a model, our models are going to pop up in the web interface. So it's really, again, the LoRa SDK and the web interface are two ways to working with GenAI Studio. Okay, so much on that. First step that we want to take in our journey here is, well, loading a model. That's quite fundamental. Well, and there are two ways how we can do this with the LoRa SDK and GenAI Studio. The first one is really just loading a model that already exists in GenAI Studio. Yeah, and Ran showed that previously, right? If we walk to our graphical user interface, open a playground, click on load model, we can see that there are a couple of models already in there, right? Llama models, for instance, MPT models, but also Falcon models. They come out of the box with GenAI Studio. And that is really something, well, you can just also access these models out of the box using the LoRa client and the get base model function. You just pointed to the handle, basically the extended name of that model, and it's going to load that model, and you can interact with it. Yeah, so you really you load your model, passing in the result of your get base model function, which is a model object, then a LoRa model object, and you point it to the resource pool that you want to use to interact with that model. A resource pool is really just a segment of your cluster that you want to use for it. Well, at this point, we can start interacting with our model. So in our case here, we loaded one of the generic Llama models that just ship with GenAI Studio, and we can use the LoRa generate method to, well, throw any query, any prompt edit that we want. And we also can, it's optional, we can also pass a configuration dictionary, you know, to just set some things like what temperature do we want to use, but also what should be the token limit of the output. So, well, and that works, right? Simple example, that works. We loaded one of these base models and fired a simple query against it. Well, GenAI Studio comes with a couple of base models out of the box. Many of them are household names. But of course, very often you want to use different models, right? You want to use some model you found on Hugging Face, maybe a model that your organization developed and pushed to Hugging Face. And that's what you want to use in the GenAI Studio context. And that is something, well, you can also do. You can load an arbitrary model into GenAI Studio using the LoRa SDK. And again, that is an important difference to the graphical user interface. In the graphical user interface, per default, you can interact with the base models that ship with GenAI Studio. If you want to interact with another model, one hosted on Hugging Face, well, then you need to fall back to the LoRa SDK. Similarly, so here we are now going to load a tiny Llama model, right? So basically just this tiny Llama model that we can find on Hugging Face. And we can load this fairly simply by just copying our model handle here and really passing this to our load model function of the LoRa client. It then, of course, is a custom model. It also asks us to specify a few more things. Some of them are fairly clear. Well, we need a Hugging Face token with read permissions to actually, you know, access that model. But also we got to tell LoRa that this is not a GenAI Studio based model. And yes, this is a model from Hugging Face, and a couple of more things that eventually define how you want to, how you are going to interact with this model on an infrastructure layer. What does that mean? Well, when I load such a model, what happens under the hood is, and that is important to remember, what happens under the hood is, on the back end, GenAI Studio uses machine learning development environment, our MLDE software product. So when I load a model here, whether that's via the graphical user interface or via a notebook using the Lore SDK, what happens under the hood is, within our MLDE instance that is connected to our GenAI Studio, actually a chat client is being spun up. So under the hood, the model is being loaded into our resource pool, distributed over potentially, depending on your settings, multiple GPUs, and an inference endpoint is exposed. Yeah, we can see here, looking into our logs now on the back end, our tiny llama model is being loaded. And once this is done, and it is done, that means now an inference endpoint is exposed, and we can again start interacting with it. So just as before, we can use Lore generate to fire any query, any prompts against it. Of course, we're using Tiny Llama now, so it's important to note, well, we also need to take into account the appropriate sequence start and end tokens for that model, right? So we also need, in that case, we also need to pass system role tokens such as system and users, as well as sequence end tokens here, to appropriately interact with that model. That is really nothing that is, that's specific to generative AI Studio, but it's really something that just depends on the model that you're using. Okay, so at this point, we have understood how we can load models using Lore, these two different ways, loading a generic base model from GenAI Studio, as well as an arbitrary model from Hugging Face. And the latter is also what we're going to continue with. Yeah? So we are going, throughout the rest of this webinar, we are going to continue using this arbitrary model, this tiny llama model. So we have a model. Once we have a model, well, we also want to load a data set, because how else are we going to understand how well this model actually works on our use case? And again, our use case is text summarization. So, well, GenAI Studio and Lore SDK give you quite some flexibility in that. You can load models in different ways. There are three different ways in essence. First, and that's the easiest way, you can just load a model that is already on the GenAI Studio dataset pool. What is that? Well, again, switching over to the graphical user interface and moving to our datasets tab up here. In my demo environment here, I've already registered two datasets to GenAI Studio. I've registered this customer complaints dataset as well as our archive abstracts dataset. So they are already available on GenAI Studio from the graphical user interface as well as the Lore SDK. And I can just use them by using the get dataset by name function here. And what I get in return here is a dataset object. Yeah, such a dataset object, it's a Lore object, a dataset object that contains some information about this specific dataset. We're not going to go into the details here, but in essence, it's a specification of what this dataset is, in which workspace it runs, when it was created, what splits it also contains. Does it contain a train split, a test split, a validation split potentially, and a few more things. It's not really important to remember, though, what this object really contains. Just good to know what we are producing here, what we are getting in return from calling these functions are Lore objects. So that's one way. If you already have a data set on your GenAI Studio dataset pool, this is what you want to do. You just want to load that data set and use it from there. That's also by far the fastest way, right? Because the data set is already on your instance. A second way how you can use a data set is, well, you can just build your local data set. And so if you have, your data set lying around on a local instance, you can just use this build local dataset function. The only thing that it asks for is really a pointer to your train files, a pointer to your validation files and test files, in case you want to have a train validation test split. And as you can see, I'm really pointing it to some local files here, to a dummy data set that I've created. Yeah, and I think the great thing to note here is also that usually, right, your training data set is not only one CSV file, but it's potentially sharded across multiple files. That is something that is being natively taken care of for you. So that's another way how we can build a data set just from local. And the third way how we can load a data set is, again, loading one, well, from Hugging Face. We are going to be loading in our text summarization data set. So just moving over to Hugging Face here, we can see that on our Determine AI Hugging Face account, we host this archive abstracts data set. And it's a super simple data set. It really just has two columns. It has a column that contains abstracts of scientific articles from archive, and has a second column that holds titles, the corresponding titles of these scientific articles. We can also see that, well, it is not a small data set. It has 262,000 rows, and it doesn't have any split. It only contains a train segment, and that's it. That's the data set that we're going to be using throughout this webinar. And we are going to be, well, evaluating our model, how well it can generate appropriate titles from our abstracts. Yeah, and then also further on in the webinar, we're going to see how we can also fine-tune our model using exactly that data set. Hopping back again into our notebook and the Lore SDK. So how can we load this data set now? It's on Hugging Face. Again, it's fairly simple. So we just, again, construct the dataset handle, and the dataset handle is nothing else but this extended dataset name. So Hugging Face account plus dataset name. That's what we need. And that we just pass to the construct dataset from Hugging Face function. We can also provide a task type. It's really optional. It basically just helps you at some point if you list your data set and you want to understand, oh, what was this data set actually about, without opening it and looking into it. Well, for example, here we just give it, we just say this is a task type summarization. So later on, it's also going to be a bit easier for us to understand what type of problem is this data set actually about. So constructing this data set from Hugging Face is fairly quickly. And again, we end up with a data set object, just as before. Well, now we learned that our data set, going back here to our Hugging Face view, only contains a train split, which is not quite ideal for our setup, because we want to understand also after fine-tuning how well our model works on their data set. So we want to split it up a bit. We want to tear this training segment apart to also construct a validation in the test split, for instance. That's something we can fairly easily do using our merge and resplit function of the Lore client. We just pass it our data set and our train test validation ratios. And in our case, well, we want to resplit our train segment because this is, well, the only one that we have. And so we can use this function to just resplit our data set, and our data set will then also contain the appropriate information about these splits, which eventually we are going to see over and over again. We can then in different Lore functions and also in fine tuning, we can then specify the right split to perform certain operations on. So now we got this data set in here in this notebook. Of course, this is usually not where it ends. Right? Very often, you also want to make this data set available on the graphical user interface and also available to other people interacting with GenAI Studio. And you can do this also quite easily by simply committing this data set. Using the commit dataset function of Lore. Once you hit that, your dataset is gonna be registered to GenAI Studio, and you can also find it in your datasets tab in the graphical user interface for others to use and for you to use in a simpler way. You're not gonna pull it in from Hugging Face from then on, but you're simply gonna use, well, the first option that we saw. Once it's in a dataset pool, you can just use this get dataset by name function to reference in a data set that's already in your pool. Well, in our case, I put this into a try except block because if your data set is already in our dataset pool, then it's going to tell you that it's going to say, "Ooh, assertion error. Sorry, your dataset is already there. No need to commit it again." Right? This is why I wrapped this into a try except block. Okay, so at this point, we have the two maybe most important parts of our workflow that we want to build out. First, in our first step, again, we have pulled in a model. We learned about two different ways how to do this. We continued with the way of pulling in a custom and arbitrary Hugging Face model. That was our first step. Second step then was pulling in a data set. We looked at three different ways how to pull in the data set. One that already exists in the dataset pool, one that we actually construct from local files, and one pulling it in from Hugging Face. Also here, we're going to continue with our Hugging Face example, so our archive text summarization dataset. Well, what's missing at this point? The prompt is missing, right? We want to evaluate our model in our context on our dataset. And for doing that, we also need an appropriate prompt. And at this point, I'm also going to briefly pause to see if there are any questions so far. Chat still looks empty, no questions?
Yeah, seems like there's no questions on my end.
Okay, good. If questions come up, please just fire them into the chat. I'm going to pause here and there to make sure I can also pick them up. Okay, so we got our model, we got our data set. Let's define our prompt. So I mentioned it before multiple times, our dataset has two columns, right? Abstract and title. So that's what we're going to be teaching our model. Our input column, what flows into our model is going to be our abstract in essence, and we want our model to generate, to output the appropriate title. So I'm just defining some constants here. And next I'm defining my prompt string. The prompt string really just is a string that at this point still, and that will change a bit later, at this point, of course, needs to still contain the appropriate tokens for our model, right? So this is why it looks the way it does. We have a system part of our prompt, which in our case says, you're an editor of scientific papers. Your task is to find a suitable title for an abstract of a scientific article. Respond only with one sentence as title and nothing else. That's our system prompt. Clear, that's a static part of our prompt. Well, there is more than a static part though, namely our user prompt. Our user prompt here is not static, obviously, but it references our abstracts in these curly brackets. So by using these curly brackets, we are really referencing a column with that name in our dataset. And again, right, our dataset contains two columns, abstract and title. So here we are dynamically referencing the value in the appropriate values in the abstract column. And we're going to see it in a second. Laura will then take care of assembling this prompt for each single item in our dataset. Finally, the assistant part of our prompt, well, that's what we leave empty, right? That's for our model to generate. We then, as a next step, once we have defined our prompt string, we push this into a prompt template. Also, this is a lore type, right? So what the only thing we pass it is our template, our string actually, with our dynamic part of the string, and we also give it a name. Again, for you, if you have multiple prompts that you want to define, multiple prompt templates, that's going to make it a bit easier to follow what prompt is actually what and doing what. So ideally, you would just give that a descriptive name for you to remember. Okay, so we have a prompt now. What do we do with that prompt? Well, we define the dynamic part of our prompt. So what we want to do next is, first of all, since this is a webinar and we have a limited time, we don't want to run everything that we are going to run over 262,000 rows because, well, that's just going to take a bit too long. So what we're going to do is, first thing, and we're only going to do this in the context of this webinar, we're going to subsample our data set. So we are going to limit the number of samples in each of our splits, so in train, validation, and test, to having 500 samples each, just to make things run a bit faster in the remainder of this webinar. The second thing we're going to do, we're going to apply our prompt template on our dataset sample using the apply prompt template function. What we pass in is our dataset sample with 2 columns, right? Abstract and title, the prompt template that we defined up here. And we also give it the name of the new column. What is this new column? Well, we are going to see that this new column that's going to be attached to our original dataset is our prompt template applied to our dataset. Yeah. Finally, we're, by the way, just printing our dataset, so nothing fancy happening in this part of the code. What we are going to get by applying our prompt template is our original dataset, abstract and title, plus 1 additional column with the name that we specified up here. So now we have this GenAI input text column. And what this really is, it is the application of our prompt, including this dynamic field that we defined, right? This curly bracket abstract in the middle, that's applied to our dataset. And Lord takes care of filling in this dynamic part of our dataset with the appropriate value that we reference. Yeah. So our user part that we can see here turns from previously curly brackets abstract to the actual value in our abstract column. And this is the final prompt that our model will actually see. So for each row, our model will be confronted with the value of this column. Okay, so we got the prompt now. We have a model and we have a data set. So now it's about understanding how well does our generic base model, our tiny llama model, non-fine-tuned, how well does it actually work, given our data set, our task, right, summarization, and our prompt. We can do this using the generate on dataset function of the LoRa client. And generate on dataset is a function that basically, takes all these things and puts them together. It intrinsically uses the model that we loaded from using the LoRa client, our tiny llama model. It takes the data set that our model should be applied on, and it also takes the prompt template that our model should use to generate its output. Again, we define an output column. This is where the output of our tiny llama model will be pushed to. And we also define a few more things, such again, a generation config, because we're performing inference here after all. And we also pointed to the correct piece to the correct split of our data set to use. So what we can see, I've already need to still trigger it. So what we're going to get as output is our original data set plus one more column now. So we already added our GenAI input text column. And what we're going to get here is 1 additional column called prompt generated text. That's going to be our output. Under the hood, what's happening, again, making the bridge to our MLDE software, machine learning development environment, because again, this is used as a backend. Under the hood, what's happening, our chat client here, right? This is our model, is in inference mode. And we are actually, as we can see here, if you look very closely, we are pinging this inference endpoint with our samples from our data set. LoRa then takes care of putting things together again. It generates a new data set, now including our prompt generated text column, so our LLM's output. And well, we can now eyeball a bit over this data set, right? In an ideal world, having an ideal model, our generated text would be very close, or at least it should have the same sense as our titles have. Yeah. Well, if we eyeball these generated titles, we are going to see that it's not quite ideal, right? So it's definitely not concise. We gave it a max token limit of 30. Well, it definitely would generate a lot more than these 30 tokens. But not only that, it also contains artifacts like the given material is a summary of a scientific paper. These are not things that you would have in the title of a scientific article. So just by eyeballing our generated output now, well, we can say it's probably not quite good. But of course, eyeballing is not what you always want to do, right? It's not really a solid way of evaluation. What you actually want to do is you want to compute some metrics, and we can do that fairly easily. And that is something, by the way, that you can currently at least not do via the graphical user interface. This is functionality that is only exists one level lower within the LoRa SDK. We can compute metrics using this compute metrics function. Again, we pass it our data set that we just generated up here. We pass it our ground truth column, which is title in our case. And we also pass it basically our prediction column. This is what our output, what our model generated, and a list of metrics that we want to compute. We're going to pass only one metric, which is the blue score, basically allowing us to understand how well does the generated text represent or overlap with the ground truth, with the ideal title, with the ideal text. LoRa comes with more than the blue score, right? So there is not only this one metric, there is also the Matthews correlation coefficient, which you might want to use for instance, classification tasks. Well, and we want to run this on our test set. Yeah. So we evaluate again on our test split, which we created before. We can also pass in some, additional help-up arguments, such as, well, do you want to lowercase everything for evaluating the blue score, or do you want to be case sensitive, and do you want to, strip white spaces left and right? I'm gonna set this to true here, but of course, this is always up to your liking. The result is, well, after executing that, our model has a blue score of 9.37. What does that mean? Well, in the context of GenAI Studio, blue score is scaled between 0 and 100. So 100 being a perfect model, essentially, but also, well, realistically not really reachable. 1 or 0 being, well, a fairly bad model. Our generic tiny llama model scores a 9.37 on our data set. So that is, well, not quite excellent, I would say. So it's fairly bad. There is room for improvement, definitely. It's not something that would now, put into production and say, yes, this now generates titles or summaries. There is some work to be done. And one of the things that you most likely want to do to make your large language model fit your problem better is fine-tuning. Yeah, fine-tuning, you probably know that, really helps you adapt your model to your specific problem, right? You want to train some parts of the model, at least, to make your model better understand what the problem that you're trying to solve is about. That's what we're going to do now. We're going to kick off a fine-tuning run using the model that we loaded from Hugging Face, arbitrary model, our tiny llama model, on our data set, on our archives text summarization data set, using our prompt. That's what we want to do. That's what we want to use for fine-tuning. So before we kick off fine-tuning, there is one thing you can do to get rid of these, well, somewhat annoying role and sequence tokens that we needed to pass in our original prompt. I'm just scrolling up here to refresh your memory. Remember, when we originally defined our prompt, we also provided it, we also needed to attach sequence start and end tokens to each of our prompt. Well, that's not something that you really want to do once this model is deployed and exposed, right? It's not something, at least, that the user who specifies these strings should take care of. So you can, that's why the first thing we do is we define formatting tokens. Formatting tokens, again, it's a class that ships with the LoRa SDK, and it allows you to define these tokens, these role and sequence tokens, once, and then attach it to your model object. That means for your model object, you don't need to pass in, appropriately formatted strings anymore. But as we're going to see, you can then pass in a Python dictionary that just, is a lot less error prone, actually. So what we do here is, well, we just define our roles. We have a system role that should always start with the appropriate system token and end with the appropriate sequence end token. The same for the user part of our prompt, which is in our example, the abstract. And we also, our output role is our assistant. And once our assistant outputs a /s, that means for our output to also end. So these formatting tokens, and we're going to see it in a bit, just make interaction with our model a lot easier. And we can attach it to when we actually instantiate our model class now. So for doing fine-tuning, we need to first create a model object. Again, a model object is just a lore data type. And it takes a few things. It takes, well, the handle to our Hugging Face model. Again, just taken from Hugging Face, just what you can see on the top left here, copy pasted into our model object, passing it to the Hugging Face model name parameter. We're passing our formatting tokens because that's what we really want to attach to our model. We tightly want to couple this. So any input that flows into our model does not need to have these, well, somewhat annoying formatted strings anymore. We also tell it a few more things. You know, this is a Hugging Face model, so the source is Hugging Face. And we should also attach the appropriate Hugging Face commit ID as well as the branch of the Hugging Face model, right? So we can really also, if there are iterations being done on that Hugging Face model, we can keep track of which exact version our model here represents. Okay, so at this point, we've created a model object. If you want to look at it, you can look at it. It contains a lot of the information we've just defined, plus also our formatting tokens, if you look very, very, very closely here. That model object is quite important. It's important for fine-tuning, but not only actually, because I think that's a very, very nice piece about GenAI Studio. You don't need to fine-tune to use an arbitrary model. At this point, since we're using the lore SDK, we can also just register this model using the register model function. And registering a model means as soon as I execute this cell, our model will pop up also in the graphical user interface of GenAI Studio to be used by anyone, right? So your colleague who maybe does not want or does not need to use the lore SDK in Python, well, you can just create that model, register it even without fine-tuning, and your colleague can then go to the graphical user interface and continue from there. I think there was a hand up. Did I just see that correctly? Maybe it was a misclick. Anyway, if there's a question, please just shoot it into the chat. So that is one way how we can make our model accessible. But well, we said we're not happy with our model, right? So we first want to fine tune. We don't want to publish our model at this point. So let's continue with fine tuning first. First thing we do is, because we specified formatting tokens, we don't need to write these awkwardly formatted strings anymore, including our tokens, but we can just define a prompt dictionary and create a prompt template out of that dictionary. And that dictionary really just contains the appropriate role names, system, user, and assistant, that is in our case, and then the appropriate prompts. Our system prompt remains the same, just that now not everything is a multi-line string, but now it's a dictionary. Our user prompt for fine-tuning also stays the same. It's just, again, dynamically providing the value of our abstract column. And finally, we pass in the appropriate title to our assistant. Because again, we are in a fine-tuning setting now. That means we want to teach our model to generate that title. So for our fine-tuning setting, we also really want to provide the correct value of the title. Otherwise, how is our model going to learn? So we just create a new prompt template now for fine-tuning. And thanks to formatting tokens, we do not need to use multi-line strings with tokens inside, but we can now use a nice Python dictionary. Well, fine-tuning, I wrapped it into a bigger function. But actually, fine-tuning is a lot easier than what this function might look like. Let's have a look at the important piece of that function. This lower piece here, that's actually how you launch a fine-tuning run using GenAI Studio. It's really this launch training method. You pass it a name of your fine-tuning job, your data set that we defined above, our archive data set, the model that we just instantiated up there, the prompt template that we want to use, and then a few more things to tell you a bit about where do you want to train. Again, our resource pool, which part of a cluster do you want to use, how many GPUs do you want to use to train it, and how you want to distribute your training. Right. So if you want to fine tune your model over multiple GPUs, well, then you can decide, do you want to use deep speed, a model parallel way of training, or do you not want to use deep speed and go data parallel, for instance? Right. These are typically important considerations that you must think about depending on your model size and your hardware, of course. So that's really what you usually need to do when you train a base model of GenAI Studio. Since we are doing a custom model, we need to provide a bit more information. We also need to provide more information about how the training, the fine-tuning should be done. And why do we need to do this? Well, if you use a base model, our GenAI Studio team has already carefully thought about what settings actually make sense. So you do not need to specify things like, how often do you want to save? How often do you want to evaluate? What should the appropriate learning rate be? What's an appropriate batch size? But since we are handling a custom model here, we need to think a bit about at least these very basic things when it comes to fine tuning. But in any case, it's fairly lightweight nevertheless, and nothing that requires, I would say, significant expertise when it comes to how to fine tune these models. So that's the logic behind our fine tuning. Now we just kick off this function, right? We just call our function. Under the hood, well, our launch training will be called, and now switching to the graphical user interface, what we are going to see in our fine tuning tab, well, a fine tuning run has been queued for now. So basically right now it's waiting for cluster resources to become available to kick off training. Yeah. Of course, I mentioned it multiple times. Under the hood, fine tuning, under the hood of GenAI Studio, there is MLDE, Machine Learning Development Environment. So what happened one level lower is, looking into our MLDE instance, actually an experiment is being launched. Yeah, we can see just now an experiment has been queued, has been launched. And that's actually our fine-tuning run under the hood. So we also get all the neat things that MLDE brings out of the box for our large language model fine-tuning via GenAI Studio. We get metrics, we get hyperparameters, we get automated checkpointing. Going to look into a fine-tuning when I launched a few days ago now, right? We can observe our training curves. We can observe hopefully our accuracy going up as well, right? We get experiment tracking out of the box here. We can look through our hyperparameters. We get intelligent checkpointing out of the box. In our case, only saving the best checkpoint. That saves you a tremendous amount of storage as well. We can go as deep as looking at the exact code that's being ran. And from here, we could also just fetch this code and continue from there at the lowest level in essence. And of course, I can also look at logs naturally. So we're not going to wait for fine-tuning to finish, but what we are going to do is we are simply going to load a fine-tuned model that I fine-tuned a few days ago on the exact same problem to speed things up a bit. How I can do that is also fairly simple. If I just waited for my current fine-tuning run to finish, then I could just use lore and say get experiment models and pass it the ID of my experiment, which I get back up here from the function call. Well, since I'm loading a model that we already trained a while ago, I'm gonna do pretty much the same. The only difference is I'm hard coding my model ID here and pointing it to the appropriate model I trained a few days ago. And then again, we just hit load model, pass it the model that has been referenced up here, and again set the resource pool that we want to use to perform inference on. Again, hopping to MLD, under the hood, what's happening is a chat client is being launched, right? So here, same thing as before happens. Our custom fine-tuned model is being loaded and is being, under the hood, distributed across our cluster if you set more than one GPU, and then an inference endpoint is being exposed. Yeah. Once our model has finished loading, which it just did, we can again, evaluate it. So we just apply it now again, just as before, on our data set to then eyeball a bit. Does it now look better? Hopefully it does. And finally, we're going to compute some metrics to then really compare, well, what does our blue score say? Is our fine-tuned model really better? So now we have ran our fine-tuned model over our data set. And again, just eyeballing, one thing that definitely works better is our titles are a lot more concise, right? They look like proper paper titles, I would say. We can also see, well, there is some similarity, definitely, right? You can see here, color groups is also in here. Whether the title is correct, by the way, I'm not a scientist, so difficult for me to say here, but at least similarity-wise makes a lot more sense. Length-wise makes a lot more sense. Just the intrinsic structure of titles now makes a lot more sense. Yeah. So at least from eyeballing it, yeah, things look related. Things look better than before, I would say. Well, eyeballing is one thing you can do, but it's not a great thing of evaluation. So again, let's compute some metrics using, just as before, our LoRa SDK compute metrics function. And we can see now on the left-hand side, model before fine-tuning, on the right-hand side, model after fine-tuning. Well, just spending a couple of minutes now, half an hour, 45 minutes on this, right? We fine-tuned that model now, and our model seems to be 2 to 2.5 times as good as before fine-tuning. And this is really only the starting point, right? So now you would start to iterate through this process. You would probably go up to your prompt, tune that a bit. You would probably change some fine-tuning settings and go through this incremental iterative process a couple of times until you're happy with your model. And again, that's what I really like to emphasize. This is what GenAI Studio really helps you to do, right? It helps you accelerate this iterative and incremental process. Fine-tuning is not a thing that you do once and then you have the perfect model, not at all. It is really something, GenAI Studio really helps you accelerate this process, getting to your return on investment of GenAI projects a lot faster. Once you're happy with your model, well, it's about using it downstream, and you can push it to Hugging Face, for instance, or you can download it, from there, deploy it to whatever application that you want your model to live in and serve your clients. Now I pushed it to Hugging Face, and we can see on my Hugging Face account, for instance, I now have a new model, which we just fine-tuned. So that's really GenAI Studio from the LoRa SDK, from the Python perspective. It really helps you, if you want to wire in GenAI Studio into your automated workflows, this is the way to go. And it really helps you accelerate your GenAI projects. It helps you iterate through this iterative incremental process so much faster than without it. And now I think I hand it over again to Isha and Ran at that point.
Thank you so much, Simon, for this incredible deep dive. Thank you, Ran. We're open for beta trial, so if you would like to sign up for that trial, the link is in the chat. And I think we can stick around for maybe 1 or 2 more minutes if there are any other questions. But if you have to jump off, I know it's already 10 a.m. Please feel free to leave. And thank you all so much for attending.
Yes, thank you. And also, Isha, I think we have one more poll to get the feedback
Oh,
from
right.
the audience.
Let's
So
do
yeah.
that.
And yeah, thank you for Isha and Simon for the deep dive. So essentially, we want to make sure that we give the deep dive to provide the value to our customers and help us to understand what's the best way to narrow the gap between day 1 and day 2. So based on this webinar, so probably the audience can see the learning from day 1 and day 2 and how fast the customers can accelerate.
We'll stick around here for another minute or so, but if not, thank you all so much for joining and have a great day. Everybody participate in the poll. All right, thanks, Ran. Thank you, Simon.